designed to make charging your Apple product easy, whilst maintaining the use of its key functions.
As you can see, the iCharge is fastened onto the socket by a small circular sheet of plastic, which is that sheet there. The plug goes through the gaps into the plastic and plugs into the socket. The circular sheet is fastened onto the main part of the device with epoxy resin. This strengthens and reinforces the back of the main part of the iCharge while simply connecting the iCharge to the socket.
Does anyone have a... The iCharge is made from high-impact polystyrene and is bent on well, it's cut out with a laser cutter into the required shape and then bent on a strip heater in 8 places to form the shape. The inner part was a polypropylene disc cut out on the laser cutter again that was then, as Mike said, glued in with epoxy resin.
Okay, so moving on to materials. The materials that we used to construct the iCharge. We used HIPS and polypropylene. The reason we used HIPS is because it's firm but yet a strong plastic. It's flexible and it enables the user to manipulate the iCharge arms so that it can fit around the iPod, depending, obviously, an iPhone would have a different size to an iTouch, for example. And yeah, when you remove the iPod, the arms will move back to its original form. Just obviously, it doesn't stretch, it won't break easily. So it's basically unique and it's ideal for any sort of Apple iPhone.
The polypropylene on the other hand was chosen because it's flexible, and we made this out of a small quantity of the recycled plastic, which is then made into a thin layer. It is very flexible and easy to manipulate, which is especially good as the user can push a plug through the gaps in the plastic without the plastic tearing away from the HDPE hips. As I mentioned before, it's fastened to the hips by epoxy resin, which is a fast drying and strong glue to use.
The cost of the material used to make this product were very minimal as they were recycled, but prices as a guide, we took some from a order catalogue used by the school, and it was £2.44 for a sheet of the hips, and that will make roughly 7 of the actual main bodies. That was £2.44 brand new, but with the recycled it would be considerably less. The polypropylene, the usage of that was minimal as it's only a very small part of the product and very thin, and this isn't expensive plastic. From these costs, we priced the product at £4.50, so we thought this was a good retail price without being too expensive, but enough to add a considerable profit margin onto the cost of the product, whilst covering production costs, including like electricity for the heating of the plastic.
And if you look at the packaging, you can also see it is very small, and that is also rather minimal. We did this by we drew a net on the 2D design tools, and we cut it out on the laser cutter. As you can see, the rectangle at the top, this is for sliding onto a rack like you would on a normal shop, and that's how it will be displayed. It is very cost effective as it's really quite small, and the only thing that would cost would be the vinyl, but as that's like very small sheet of vinyl, it would be too expensive. And basically we just added the vinyl to make it look more aesthetically pleasing, as it was just regular cardboard underneath.
Okay. The logo, we designed the logo using Macromedia Fireworks. It's quite a basic software, but it was perfect for what we needed to do, really. We wanted to keep the branding and the logo just clear and quite like, not blunt, but I don't know the word I'm thinking of, but yeah, simple, clear and simple. So we decided upon a font, and all we did, because of the charge, we just decided to put the lightning bolt across the top. Originally it was going to be down the side and the lightning bolt above the eye, but we didn't want to copy we didn't want to stay along the lines of the apple theme, because we were also going to have an apple within the shape of an apple, because obviously the product's for apples. But we wanted to make it a bit more unique and a bit more to do with us, not to do with apple. So yeah, and then we went for a good colour contrast, we feel. The black and yellow goes very well together, the yellow stands out, it's bold, clear. And yeah, we printed that off using the vinyl and the vinyl printer.
For our design ideas, we initially started out with a design that's already on the market, but it doesn't work well with UK sockets as it fouls on the switch. It also doesn't actually hold the product, it just rests on the shelf there. Also, a lot of chargers that relied on the charger having a large transformer on it to hold the product in place, whereas a lot of Apple chargers are very minimal, so they don't have bulky transformers. Next we moved on to ideas like this, where we would have a bay on the bottom to hold it, and then arms to stop it from falling off sideways. We thought that was getting quite messy and complicated. Then we thought about holding it on all four corners, but again they'd have to be very thin arms, and it wouldn't be very strong, and would be difficult to actually manufacture. We then finally went for this design as it held it securely, was simple to make and simple to use, and the added disc of polypropylene would hold it onto most UK sockets without problems. Any questions?
Very good.
Is there a way of manufacturing it so that it could be kind of global, with a different?
Yeah, well, we could. There's a possibility of injection molding, but the trouble is that it's quite a thin product, so it might struggle with the injection molding. But the other thing would be.
With different configuration of.
Oh yeah.
Actual pin sockets, you can have two pins.
Yeah, you could just reload it and just stick a new polypropylene insert into it during production.
It's also in European stuff you have different plug, don't you?
Yeah. So I just wondered whether European holes would actually come 5 holes on there rather than 3.
Yeah, that's a very good option.
This could also work for different types of products, like this is my Sony Ericsson phone, and as you can see, it does fit into it without changing much. So in the future we could change this to adapt into other products, not just Apples.
We forgot to mention one thing actually, was the grips we placed on the inside of the grips, if you like. We just put a rubber, just like a rubber material, just to hold it in place.
That was again keeping with the recycled theme. They were made from old bike engines, and they're plenty available due to that.
Did you experiment at all with the length of these? I mean, these in a kind of in a polymer terms, polymer component terms, this is a lever.
Yeah.
And the lever length needs to relate to how much it moves. Otherwise, the material is stressed.
We did try it with other shapes, and the longer we did try it with we made a prototype of an earlier version, and that had longer arms, and it had a longer arm on the top.
Yeah.
But it then sagged and fell out of the top arm. But where we put the top arm shorter, it now leans back into it, and it makes it easier to use while it's still in the charger as well.
So actually, what's happening when you put the charger in is that it's the bottom arms that are moving really.
Yeah, and the top one flexes slightly, but not as much.
We have also tried with a different material, but when we were making it, it was a much more flexible material, so it didn't move, stay in place. So would just fold back down if we moved it up again, especially when we dent it. So
because during the strip heating it had a much higher melting point, so to get it to that temperature it needs to heat a lot more, and that caused it to heat a lot of the plastic around the bend.
Yeah.
So the bends were very inaccurate and large, and it didn't work very well.
Folding it in with your strip heater, it must have taken quite a while as well to sort of put it in, fold it.
We had them all out in a staggered process along the one strip heater, so we could do them all.
So you did the same fold at the same time?
Yeah, and then just had a former to bend them around.
Yeah. So you mentioned injection moulding. Did you look at? I know the brief for this was about what you had available to you. You mentioned it, and did you look at that a little bit?
We were just. That was just a plan that if we got how it could be expanded into mass production, how it could be manufactured. We thought that would be impossible.
This is interesting, isn't it? Some of these things that in mass production, and you injection mould it, and actually the form that you have is quite impossible to injection mould in a way, because it's you have to think of a jelly mould and getting something out of it. But actually, because you've formed it like this, you've made something that would, in that profile, is impossible.
Yeah.
But as a three-dimensional object, is quite possible, because what you would do is that would have what we call a side action coming through here, and two side actions there. When we allow you to get that out of the tool as it was. So it's, it's interesting in a roundabout way. Both your consideration of the lever length is very good, very important.
Thank you. Cheers. Thank you very much.